example 2 is going to be a simple pendulum. So when we're looking at simple pendulums, we have a mass or a bob on the end of a string, and that string is going to be able to oscillate back and forth. At the high places, when the displacement or the angle is the greatest, it's going to give us the greatest potential energy, and it'll be the least at the bottom. Okay? So here's some things, some simple things to identify with a simple pendulum. Okay? When we look at amplitude, that is that angle from that midline. So that middle dotted line, that's that angle from there. Okay, so that's what we mean by amplitude. Some say angular displacement. Okay, the period is the amount of time for that bob to start here, swing away, and come back. How long does it take to complete one cycle? One cycle of motion. That's what we mean by a period. Now the frequency, let's think about this. How many times per second do we get a complete cycle? That's a little bit different way to think about it. In fact, it's inversely related. They are inversely proportional. As you increase the period, you will decrease the number of waves or complete oscillations that you have. And that's what we're talking about here. And frequency works the same way. If you increase the frequency, you're going to decrease the amount of time it takes to complete one cycle. That's just the way that will work. Now there are some relationships that affect that. So as I go in, and if I change the length, it should move faster, right? It's got a shorter distance to cover, and so it's going to move faster. It'll do a complete cycle in a shorter amount of time. Notice a while ago at 1 meter it took 2. Now it's taking 1.1 at 0.3 meters. So that's the length matters. Another thing that can matter if I pause and I stretch this guy way out, another thing can matter is gravitational pull. So if I make it really small gravitational pull, notice this is what will happen. Nothing. Okay, so what if I give it a little bit? Now we see it's moving really slow. Okay, that's a big deal. Okay, now if I give it a lot of gravitational pull, it'll complete the time. So if I come out here to 30 again, the same amount that I've been trying to do the whole time, you'll see that it'll complete it pretty fast. Okay, 1.2 seconds. So that gravitational acceleration due to gravity as well as the length are the two things that affect. It doesn't matter how big the mass is. If I set the mass at 1.5 and I push play, and I'll get the same amount of time that if I put it at 0.1, which is a radically different mass. So the mass does not affect. That's a big deal. So I want you to make sure you get that out of this today, that length is directly proportional and gravity is inversely proportional to the period. And so we'll get to that and we'll kind of go look on the next slide. So the period of the pendulum is this equation. Okay, here's the period of that pendulum. If you increase the length, you increase the period. So that's a direct relationship. If you decrease the length, you decrease the period. That's a direct relationship. However, if you increase the gravitational pull, you will decrease the period. If you decrease the gravitational pull, or the acceleration due to gravity, then you will increase the period. That's an inverse relationship. And here is the equation that you will use to solve. I hope this helped you with your time. If you got any questions, please don't hesitate to reach out.